Hey guys, hope everybody's doing well. This is going to be the first lesson of our online learning. It's going to be a little bit of a review that the things that we were working on right before we had spring break. So we were talking about the unit circle and then the 6 trig functions and how to use them on the unit circle. Okay, so most of this is going to be a little bit of review, a little bit of a refresher. So I'm going to just draw out what an angle would look like on the unit circle. I have my x and my y axis, and then I have my circle. Okay, and then we were talking about if you have an angle, your initial side, you have your terminal side, right? That terminal side goes through a point. Okay, we call that x and y, obviously, right? So your 6 functions are all based off of going through that particular point. Because what you have now is a right triangle, right? So you know that this distance here from the center to this point here, right, that would be x. The vertical distance would be y, and then the radius goes from the center to the point on the outside, right? And we were always saying that the radius comes out to be 1. Okay, so you have your 6 functions. So the first one would be sine, right, which we said was y over r. Okay, now if we're talking about the unit circle, right, we know that the sine function always just goes with the y term, right? Because if r is 1, y over 1 is just y. Okay, now the reciprocal of that one, right, we know is cosecant, or r over y. Okay, then you have cosine, which is x over r. Opposite of that is secant, which is r over x. And then you have tangent, which is y over x. And then cotangent, x over y. Okay, so those 6 functions you guys really need to make sure that you're remembering, because it's going to help you a lot when you're evaluating all of these functions together. Okay, so you can have the unit circle out in front of you. You don't really need to have it in front of you, because really, as long as you guys can remember, the first quadrant here. Okay, the rest of them are all based off of reference angles and reflections and things like that. So I'm really only going to focus on, how does it relate to the ones in the first quadrant, and then kind of go from there. Okay, so this first one says 5 pi over 4. Okay, so I know that this is a pi over 4 angle. Okay, and I have 5 of them, right? So at pi over 4, okay, if you look at your unit circle at pi over 4, right, you have root 2 over 2, root 2 over 2. Okay, so when I evaluate the functions, that's the coordinates that I'm going to be using. Okay, now when I'm using 5 pi over 4, I just have to figure out where on the circle does it fall. Like where on the axis does it go? Okay, so I know 5 pi over 4, right? If I draw that out, 5 pi over 4 is going to go in quadrant 3. All right, because you got 8 pi over 4, 4 pi over 4. This would be 2 pi over 4. 6 pi over 4, right? So if I draw 5 pi over 4, I know it's going to go in quadrant 3, right? So anything in quadrant 3, the x is negative and the y is negative, okay? So what I'm going to do is I'm going to take the coordinate that I just found for pi over 4, because that's coming from quadrant 1, and I just need to make sure that my x term is negative and my y term is negative, because we're using it for 5 pi over 4. Okay, so again, it all goes back to, as long as you know the first quadrant, everything else is pretty easy. All right, so you have sine of 5 pi over 4. All right, now sine goes with the y term, okay? Now, this needs to be the negative y term, right? So the negative y term would be negative root 2 over 2. Okay? Now, the opposite of that, cosecant, all right, it's just the 1 over that term, right? It's 1 over the y term. All right, so this becomes negative 2 over root 2, which is then negative 2 root 2 over 2, which is then negative root 2. All right, you're just going to keep simplifying as you go through. All right, so then you got cosine. All right, so cosine goes with the x term. All right, so sine is the y term. Cosecant is 1 over the y term. Cosine is the x term. Okay, now it's going to be the same thing, right? So it's going to take the x term, but I'm going to make it the negative. So negative 2 over root 2. And then secant, which is 1 over the x term of 5 pi over 4, is going to be the same thing as it was before. And again, you guys can simplify that. Okay, and then the last one, right, you got is tangent. Okay, now tangent, the rule for tangent is y over x. All right, so essentially what I'm going to do is I'm going to take my x and my y term, and I'm going to put them over each other. So you got negative root 2 over 2 over negative root 2 over 2. Which simplifies to be positive 1. And then cotangent is just the opposite, right? So that's x over y. Which in this case, because they're the same coordinate, it's going to come out to be 1 as well. Okay? All right, so again, you're just figuring out, all right, where, which coordinates am I using from the first quadrant, okay? And then based off of where the angle goes, you figure out if the x terms are negative or positive. Okay? Now this second one, 3 pi over 2, right? 3 pi over 2 3 pi over 2 goes there, right? So we know that the coordinate at that point is 0, negative 1. All right, so this one's pretty easy because it goes right on the axis. So you got sine of 3 pi over 2, which is the y term. So that's just negative 1. And then cosecant, okay, that's 1 over the y term, which is also negative 1. So then you got cosine, which is the x term, which is 0. And then secant, which is 1 over the x term. That is going to be undefined, right? You can't divide by 0. And then you got tangent. All right, so that's going to be the y term over the x term, which is undefined. And then you got cotangent, which is the x term over the y term, or 0. Okay? So that's how you come up with the ratios based off of the angle that you're given, right? And again, all I really did is, again, you're just using quadrant 1, right? If you guys remember the trick that I showed you, 1, 2, 3, and then 1, 2, 3. You guys can look that up online too. There's a lot of videos that talk about the 1, 2, 3, 1, 2, 3 trick. It's pretty easy just to remember the first quadrant. All right, so then let's work on, again, coming up with the exact values based off of the angle that we're talking about. Okay, so this first one, sine of negative 7 pi over 6. Okay, so my angle that I'm working with, right, is pi over 6. Okay, so the coordinate at pi over 6, right, is root 3 over 2, comma, 1/2. Now you guys can look on the unit circle to check your work. Okay, so now what I have to do is I need to figure out where does negative 7 pi over 6 go, and then I can figure out, you know, what's if x is negative, if y is negative. All right, so if I draw out 7 pi over 6, negative 7 pi over 6, right? One time around would be negative 2 pi, or negative 12 pi over 6. Half time around would be negative 6 pi over 6. 3 pi over 6. 9 pi over 6, right? So 7 pi over 6, if I draw the angle, right, has to go in quadrant 2, right? This would be negative 7 pi over 6. All right, so anything in quadrant 2, right, you guys know that the x term is negative and the y term would be positive, okay? So I'm going to be taking the coordinate that I just found, right? And I have to make sure that my x term is negative and my y term is positive. But since I'm talking about sine, I only need the y term, right? And the y term is going to stay positive, right? So my answer is just 1/2. Okay, now if I had to, say, do cosine of negative 7 pi over 6, all I would have to do is just make the x term here. I would just have to make that negative, and that would give me the answer, okay? So it's, again, using the first quadrant and then figuring out where the angle goes. Okay, the second one, you have tangent of 16 pi over 3. All right, so we're dealing with pi over 3 here. So pi over 3 from quadrant 1 is 1/2 and root 3 over 2, okay? So I know when I do tangent, I have to do the y term over the x term, okay? So now I just have to figure out, you know, where does 16 pi over 3 go? Okay, so 2 pi would be 6 pi over 3. Half of that would be 3 pi over 3. Half of that would be 1.5. And then in between would be 4.5. Okay, so if you guys go around one whole time, right, that's 6 pi over 3. If you guys go around again, that's 12, right? So how much is left, right? After 2 rotations of 12 pi over 3, right, I'm left with 4 pi over 3. So 4 pi over 3 would go in quadrant 3. Okay, so it's in quadrant 3. All right, so anything in quadrant 3, I know that the x term is negative and the y term is negative. Okay, so I just have to take my coordinate that I found, right, and make them both negative. So when I do the y term, it's negative root 3 over 2 over negative x term. All right, and then when you guys divide the fractions out, you get positive root 3. Okay. All right, cosine of 7 pi over 4. So pi over 4, root 2 over 2, root 2 over 2. Okay, now 7 pi over 4 goes in quadrant 4. Right? It's almost one full time around. Okay, so now quadrant 4, x is positive, y is negative, all right? But since we're talking about cosine, I only need the x term. So the positive x term here is going to be root 2 over 2. Okay, so secant of negative 5 pi over 2. All right, so you just got to figure out where does negative 5 pi over 2 go. Okay, so if you go one time around, that's negative 4 pi over 2, or 2 pi, right? And then how much more do you have to go, right? You have another pi over 2 to go, right? So that's going to be right here. So this is going to be negative 5 pi over 2. So the coordinate there, 0, negative 1. Okay, so when I'm doing secant is 1 over the x term. Now the x term here is 0. Okay, so this is going to come out to be does not exist. Can't divide by 0. Okay, so cosecant of 2 pi over 3. All right, so again, pi over 3 here is 1/2, and then root 3 over 2. Okay. Now 2 pi over 3 goes in quadrant 2. All right, anything in quadrant 2, the x term is negative and the y term is positive, right? Now I only need the y term, right? Because cosecant is 1 over the y term. Okay, so this is 1 over the y term. Now if you guys simplify that, that would be 2 over root 3, which is then 2 root 3 over 3. All right, so the more practice that you guys get with this, the better you get at it. You don't have to draw them out every time. It should really become kind of like second nature. But if you're having a hard time coming up with them right away, I think it's a good idea to to draw the angle out first, and then you can figure out the coordinates second. Okay, so 5 pi over 4. 5 pi over 4 I know is in quadrant 3. Okay, now we have quadrant 3, which is negative x and negative y, right? So this goes back to the angle at pi over 4, right, which is root 2 over 2, root 2 over 2, right? So since we're using 5 pi over 4, I just have to make the x term here negative and the y term negative, right? Now cotangent, the ratio for that is x over y. So I'm going to take the x term here and make it negative, divided by the y term, which is also negative. And if you got, since they're the same thing there, your answer is just 1. Okay, so these last two, they're a little bit bigger, right? So talking about 45 pi over 6, right? So the angle that we're using is pi over 6, which is root 3 over 2, and 1/2, right? Now I need to figure out where does 45 pi over 6 go, right? Okay, so I know that one time around is 12 pi over 6, right? Because that's 2 pi. Then you got 6 pi over 6, 3 pi over 6, 9 pi over 6. Okay, so you have to think of how close does 12 pi over 6 get to 45 pi over 6. Okay, so you have to think of like how many full rotations are you going to have here? How many full rotations? Okay, so if you think of, if you go around 3 times, now you want to make sure you don't go over. You don't want to go over 45 pi over 6. Okay, so if you go around 3 full times, right, 12 pi over 6 times 3 is 36 pi over 6, right? So 3 rotations is 30, so we're going to do, so 12 pi over 6 times 3 is 36 pi over 6, right? How much do you have left, right? So 45 pi over 6 minus 36 pi over 6 gives me 9 pi over 6. Or, if you simplify that, you go to 3 pi over 2, okay? So 45 pi over 6 and 3 pi over 2, they're going to give you the same answer, right? They're coterminal with each other, all right? So 3 pi over 2 goes right there on the y-axis, okay? So this actually simplifies a little bit. We actually don't need pi over 6 right away. So I did a little extra work. So we don't actually need that there. Yeah, so sine of 45 pi over 6. So sine of 45 pi over 6 is the same thing as sine of 3 pi over 2. Okay, now the coordinate at 3 pi over 2 is 0, -1, right? So since we're doing sine, we're going to use the y term. So your answer here would just be -1. All right, so once the angles get a little bit bigger, you guys can, I would recommend maybe using a calculator. Again, figuring out how many full rotations do you have inside the angle that you're talking about. Figure out what it's coterminal with, and then go from there. All right, and then the last one here, cosine of -75 pi over 4. Okay. So again, figure out where does that go, right? What is -75 pi over 4 coterminal with? Okay, so one time around would be -8 pi over 4, right? That's one full rotation. All right, so just label your axis, right? All right, so again, this might be a good idea to get your calculator out. All right, how close to 75 can I get using 8 pi over 4? Okay, now I know that 8 times 9, right, is 72. So again, you're looking for how many full rotations. Okay, so if you do 9 rotations, that's going to be 9 times -8 pi over 4. You're going to get -72 pi over 4, right? So what do you have left, right? The difference would be -3 pi over 4, right? You have -3 pi over 4 more to go, okay? So -75 pi over 4 and -3 pi over 4, again, are coterminal. Okay, so -3 pi over 4 goes in quadrant 3. Quadrant 3, right? So we know that the x term there is negative and the y term there is negative, okay? Now the angle that we're using, right, is pi over 4. So pi over 4, root 2 over 2, root 2 over 2, right? So if I'm doing cosine of -3 pi over 4, right? -3 pi over 4, -75 pi over 4 are coterminal, so they're going to give me the same answer, okay? So I just have to look at my coordinate that I'm using here, using the x term, I just have to make sure that it's negative. So you have negative root 2 over 2. All right. So if you guys have any questions, please let me know.